I would like you to imagine a world of electric vehicles with no charging stations. That is the technology we are talking about. This is the application of space-based technologies for a carbon-free future. But first, I'd like to introduce myself. My name is Raymond Chukwu. From an orphan to overcoming poverty and crossing a line nobody believed could be crossed, I made myself an extraordinary aerospace engineer with particular emphasis on aerospace medicine. My training from the best aerospace engineering universities and my captivating and professional background and experience from Lockheed Martin distinguished me with a vision to establish black technologies advancement, to explore the applications of space-based technologies, to accelerate a vision of a carbon-free future and the creation of 7 planet change solutions through the research and development of space-based solar internet network system as the de facto charging mechanism for wirelessly charging electric vehicles while driving. Now, this is what I'm talking about. The charging is direct from space, and this is why it's necessary for us now to start to explore the applications of space technology to benefit everybody here on the planet. This will be the first in a series of space-based wireless power transfer services to be developed for wireless charging electric vehicles while driving. It will not only be based entirely on no commercially available developmental or experimental techniques evaluated to date, but it will also be the first time in our history that average families will directly benefit from the applications and utilization of space-based technologies here on the planet. The responsiveness of this technology to market demand, as well as technical approach, merits, and the level of innovation have been demonstrated in the video animation at the link below. In the link, the contact information for Black Technologies Advancement is there. The phone number and the web address is in the animation. So at the end of the animation, you get all the information you would need. If you need additional information, that's when you can contact us. And thank you for watching.
We can no longer ignore the fact that the revolution for electric vehicles is here to stay. Black Technologies Advancement, BTA, discusses space-based wireless solar internet network system as the de facto charging mechanism for wirelessly charging electric vehicles while driving. Did you know that the U.S. electricity demand will increase by about 39% by 2030? That means that about 6 billion megawatt hours of electricity will be consumed by 2030. Internal combustion engine-powered vehicles accounts for about 55% of this consumption, which is more than all the U.S. domestic oil production. This spike poses serious environmental concerns. Black Technologies Advancement (BTA) mission responsibility in this undertaking is to create a planet-saving and carbon-free environment that will replace these engine-powered vehicles. BTA space-based technology will assist the automobile industry to sustain this revolution. With the prediction that there will be about 9 million electric vehicles on the road by 2030, with the anticipated sales of pure electric vehicles reaching about 160% in July 2019. To successfully sustain this revolution, Black Technologies Advancement plans to base this technology on no commercially available, developmental, or experimental techniques evaluated to date. This will be the first in a series of wireless charging system to be developed for electric vehicles while driving that will be based entirely on no commercially available developmental techniques evaluated to date. System key components. The operating mechanism is organized into 3 separate components, which include transmission unit, receiving unit, vehicle remote charging (VRC) unit. The transmission unit. The transmission unit is the space-based solar power SBSP satellite. It is considered the backbone of the system. Its mission responsibility is to maintain steady energy transmission with no interruption 24/7, using solar energy collector, large antenna, and direct current converter, while orbiting at about 22,300 miles above sea level without any cloud cover. The receiving unit. The receiving unit will consist of several embedded actuators, sensors, and processors. Through computer simulations and mathematical predictions of the behavior characteristics of these parameters, we will run a closed-loop simulations of these parameters' operating environment on BTA Superior Artificial Intelligence Computer Workstations processor to accurately define how the expert knowledge will be coded to recognize and adapt to changes in dynamic system, such as temperature, incident angle, and electrical characteristics, in order to accurately train parallel processing neural network model of the motor program generator (MPG) to emulate pursuit eye movements, which is the control of the eye movements in response to the behavior pattern of the communication links between the eyes designed as receiving unit and the brain designed as vehicle wireless remote charging system on the vehicle. With this, algorithmic models for workload assessment in conjunction with the receiving unit command module simulation, we can establish a relationship between the receiving unit and the vehicle wireless remote charging system functioning as a unit to accomplish the following tasks. The receiving unit wireless power sensor nodes network as interconnectivity sensor nodes and transponder via standard radio frequency and Internet of Things IoT signal will acknowledge transmission and receipt of the power to the vehicle. The aiming unit will track the transponder signal to follow the path of the vehicle and aim the power beam at the vehicle wireless remote charging system on the vehicle. The data link between the receiving unit and the vehicle for data exchange will utilize Automated Reasoning Tool, ART, as the data exchange facilitator between the vehicle and transponder signal to maintain the required communication. To achieve the required interaction between the receiving unit and the vehicle, the geometric characteristics of the receiving unit must be defined to assess the followings: the distance between the receiving unit and vehicles, the wavelength, the diffraction limit used in standard radio frequency antenna assessment, the range and size of the radio frequency beam. The de facto charging mechanism will be based on wireless power sensor, WPS nodes, and radio frequency, RF beam. To determine a power transfer efficiency, we performed theoretical computation on the Friis transmission equation and compared our result with laboratory experimentation and testing to evaluate performance parameters to assess operational safety, convenience, reliability, flexibility, interoperability, efficiency, life cycle costs, use patterns, and range capabilities to generate the required data, such as a power transfer efficiency, nominal power transfer, a gap spacing and alignment flexibility over a reasonable range, consistent with conditions that would be experienced in real-world conditions, This will provide the receiving unit with the intelligence necessary to respond to any signals or alerts generated by the vehicle wireless remote charging system on the vehicle for refueling. The performance of the vehicle wireless remote charging (VWRC) system can be optimized through the integration of onboard experts in the form of dedicated expert systems into the normal vehicle operation and decision loop. A typical onboard expert would provide expertise on the vehicle and the receiving unit to accurately and wirelessly track, aim, and guide the energy beam to the vehicle in the following manner: continuous adjustment of the movement trajectory to a given sensory input. Example, a small target for pursuit eye movements. Learning of a desired movement trajectory. Prediction of the immediate future of the trajectory. Retrieval of a previously learned trajectory. Thank you for watching. For additional information, please contact Black Technologies Advancement at www.bta2tv.com or call 408-244-7852.